Okay, we are starting section 6.4.
All right.
Rational number is any number that can be written as a fraction. A rational number is any number that can be written as a fraction. Yes?
All right.
Now, whenever I say a rational number, that is going to be power over root. Power over root. Okay? The power is the number that goes to the base, and it's the exponent. The root is the index. You with me? That is the radical, the cube root, the fourth root, the fifth root, the 10th root. Now, if you have a fraction that is negative, the negative may never go with the denominator because the denominator represents the root, and you can't take a negative root. You with me? So the negative goes to the numerator. So here we go, some examples. Write each expression in radical form. So please write the first example down. X to the 9 over 2 power. X to the 9 over 2 power. The first thing I want you to identify is your base. What is your base? X is your base. So what I want you to do is to write your radical, put your base in the inside. What is the power? Power over root. What's the power? The power is 9. That goes on the inside with the x. And what is the root, which is the index? The 2 goes here. Do I need that 2 there? No. So you are actually just have the square root of x to the 9. Do we understand that? Explain? Someone say to explain? Are we good? All right. Okay. This 2 is understood to be there. You can't have the 1th root. The lowest root you can have is the square root. So it's understood to be there when you don't see it. It's the phantom 2 for roots. You with me? Okay. X to the 3/4. So what's the first thing we do? Identify your base. My base is x. So I'm going to draw my radical. I put my base inside. What is my power? That goes inside with the x. And what is my root? That goes on the index position. Do we understand that? Done. Make sense? That's it. Okay, keep on going. X to the negative 2/3. Where's the negative go? It goes in the top with the power. Do we understand that? It may not go to the bottom. Yes? So we identify our base. What's our base? So we go ahead and we write our radical symbol, putting base in the inside. Our base x. What's my power? And what is my index? Done. Yes? Okay. How is the next one different? It's a decimal. I need to turn it into a fraction. So how do I go about doing that? Well, negative 1.4 is the same thing as negative 1. And what place value is the 4 in? The 4/10. What does 4/10 reduce down to? Negative 1 2/5. The negative hangs out, right? 5 times 1 is 5, plus 2 is 7/5. Do we all understand that? So the problem that I'm actually doing is x to the negative, is x to the negative 7/5. Do we see that? So now, what do we write? Our radical, our base, the power is, the index is, done. Do we understand that? Now let's go the opposite direction. The opposite direction is I give it to you in radical format, put it in exponential format. So, what's my base? X. What's my power? What's my root? Done. Yes? Second example on there. Careful. How many bases do I have? I have 2 different bases. Do we understand that? I will get you. Be very careful. Okay? So if I have 2 different bases, I need to put on my phantom exponents, right? So which one has the phantom exponent? The 5, right? So I need to put that 1 on that 5. So my base of 5 has an exponent of 1 with a root of 3. My base of y has an exponent of 4 with a root of 3. Do we understand that? Yes or no? Last example on the slide. How is this different than the previous one? It has parentheses, which means, yes, there's technically 2 different bases, but the parentheses are grouping them as 1. Do you understand that? So you're going to keep the parentheses, and you're going to utilize the parentheses, and you're going to say the power is 3, and the root is 2. Do we see that, yes or no? Easy. Make sense? Okay, now let's take this concept and actually apply it with some problems. So I give you simplification. Simplify 64, or 64 to the 1/3 power. That 1/3 power generally messes with our head because it's a fraction. What do we know a fraction to be? Power over root. So I'm immediately going to say, okay, well, I'm going to write this in the way my brain understands it. So I'm going to put my radical there. What is the base? 64. What is the power? 1. And what is the root? So what is this actually asking for? The cube root of 64. And what is the cube root of 64? It is 4. How many of you did not understand this, but you do understand the cube root of 4? Does that make sense? Okay, let's look at the next one here. 3 to the half times 3 to the 3rd times 3 to the 2/3. Listen to my question and please answer it. Think before you speak. How many different bases do I have? How many bases do you see up there? There's 3 bases. They're all exactly the same. Do we understand that? Yes? So by rules of exponents, what do I do with those exponents? I add them together. So this is going to be 3 to the 1/2 plus 1/3 plus 2/3. Now, you should be able to logic your way through this. 2/3 of a candy bar and 1/3 of a candy bar gives me a grand total of a whole candy bar, right? So a whole candy bar and a half a candy bar gives me 1 1/2 candy bar, which gives me what fraction? 3 to the 3/2 power, yes? That's just logic skills. If you don't like those logic skills, simply type it in the calculator and get 3/2. It's totally fine. Okay? Now, do we like it written like that? So what do we prefer it as? A radical. So write this as a radical. If I write this as a radical, I'm going to have radical base of 3. What's the power? 3. What's my root? Is my power of 3 divisible by my root of 2? No. Do you remember on Friday, I wrote all those S's over there on the board, and we partnered up according to the roots that we had? Yes? So I need to go ahead and I'm going to break this down into 3 squared times 3 to the 1st. Yes? Well, 3 squared is 9. What's the square root of 9? Okay, this just power and root cancel out to give you 3 square roots of 3. It's uglier. It's a little bit uglier, but the philosophy is all there, yes? Okay, let's go ahead and I'm going to pass out tonight's homework. Don't write on those yet. Okay, you guys go ahead and start those. Okay, here we go. T to the negative 2 over 7. I need to write that as a radical. No, this is your homework. This is number 3. This is right off of your homework. Okay. T to the negative 2 over 7. So I need to write my radical, put my base. Where's the negative go? With the 2 on the inside, the 7 is the index. Do we understand that? Okay, number 4. What is 2.4 going to be? 2.4 is going to be 2 4/10, which is 2 2/5, which is 12/5. Do we all understand that? Yes? 4/10 is 4 over 10, which reduces down to 2/5. 5 times 2 is 10 plus 2 is 12, yes? So my problem is m to the 12/5. So if I do a radical, I put my base of m on the inside, and what is my power? And what is my root? Do we see that? Yes? Okay. The next set of instructions. Number 6. Five AB is all one base. My power is 3 and my root is 4. Do we all understand that? Yes, it will be wrong. You must put the parentheses there. Okay? Okay, number 8. What's this one going to be? What's my base? N to the 4 over 5. Done. Yes? Okay, next, number 10. Number 10. What is my base? So they're all the same base, right? So what do I do with the exponents? So this is negative 5 in parentheses. 1/3 plus a third plus another third is going to give me 3/3, which gives me 1, which just gives me negative 5. Yes? Number 13. Oh, because what's anything to a power of 1? Itself. Okay, what do I do? I have 2 different bases, so I can't marry the exponents, can I? So I have to go straight to radical form. So what is the radical form of 18 to the 1/2? Tell me it. The square root of 18. What is that's 98 to the 1/2 power. What's the radical form of that? Square root of 98. Now guess what? My roots are the same, aren't they? So now I can marry the stuff underneath of the root. Do we see that? So I am not going to multiply those together because I don't want to grab a calculator. But what I can do is say, okay, 18. What are the perfect squares of 18? 9 times 2. What about 98 divided by 2? What's 98 divided by 2? 49. Okay? So this is 9. I have 2 2's in there. That's 4. And this is 49. Those are all perfect squares now, aren't they? What is the square root of 9? What is the square root of 4? What is the square root of 49? So 3 times 2 is 6 times 7 is? I did that all without a calculator, didn't I? Right? How many of you would have grabbed a calculator to do that if you wouldn't have sat and thought about it for a minute? Does that make sense? Excellent job. Okay, moving right along. Number 16. There's one base, and what is the base? Negative 27. So I have a radical, and I put negative 27 on the inside. Then what's my power? And then what is my root? Okay, listen. Listen to my question. When you raise a number to a power, does it make that number larger or smaller? Larger. What if you take the root of a number? Does it make the number larger or smaller? Smaller. Now, does your brain work better with larger numbers when doing calculations or smaller numbers? Okay, so tell me, would I want to do the root first of this, or would I rather do the power of this? The root will make it smaller on my brain. So I can rewrite that and put the power on the outside. You know why? Because multiplication of exponents is commutative. 5 times 2 is 2 times 5. It doesn't matter the order that you multiply numbers in, the outcome will be the same, correct? So that's what gives me the opportunity to go ahead and do the root first before I do the power. So what number multiplied by itself 3 times is negative 3? Negative 3. So this comes out as a negative 3. Do we understand that? Now what's negative 3 squared? Positive 9. Did anybody in here know what negative 27 squared was off the top of your head? No, but you did know what the cube root of it was, didn't you? Do we all understand the beauty of that problem? Yeah? Okay. Now, number 17. 7 to the 0 is 1. Always and forever. 1. Always and forever. Anything raised to the 0 power is always and forever 1. Yes? 21. Same base. What do? Add them. Add those fractions. So I have y to the 2/5 plus 3/8. Who has a calculator in front of them and can add those together for me? At least he has one. It is 31 over 40. It is 31 over 40. The quickest way to do that is to understand that 5 times 8 is 40. So literally in your head, take 8 times 2, that gives you 16. 3 times 5 is going to give you 15, and if you add them together, that gives you the 31. Okay? Now, we're not done. What do? Put the radical, put the y, my power is, my root is, goes on the outside, done. Do we understand that? Yes? Okay, 23. What's going on with this one? Okay, is there a power on the outside of the parentheses? Yes, but whenever you do this problem, what do you always have to look for before you do any distributing? Phantom exponents. You need to look for any bases that have a missing exponent. Is any base missing an exponent? The 3. How many of you would have skipped the 3? Do we all remember you cannot do that? Okay, so now multiply. And guys, I'm not going to skip a step. I'm going to just go ahead and do the multiplication and then simplify it. Okay? It's easier to waste your time writing extra work than it is to simplify incorrectly in your head. So this is 3 squared. A to the 2 times a half. 2 times 1 is 2 over 2. B to the 2 times 1 is 2 over 3. Yes? What is 3 squared? Okay. What is 2 divided by 2? So that's a to the 1st. What is b to the 2/3? Do we like that? So how do we write it? A radical. Put the b on the inside. The power is, the root is, done. Do we understand that? Yes, sir. Because we don't like fractional exponents. Make sense? That's the reason right there. We good? Okay. 25. It's ugly. It's okay. What do? It's the same exact problem as the last one. Do I have an exponent on the outside of the parentheses? Yes. So I need to look for phantom exponents. Do I have any? On the y. Next, what do? Distribute to every single base on the top and every single base on the bottom. So this is going to give me x to the negative 2/3. Where does the negative go? On the top. The y to the second, all over. X to the 4/3. Y to the negative 2/2. Notice how I am not doing any simplification. I'm taking it one step at a time. So then, can I simplify the first x in the numerator? That's negative 2/3. Can I do anything with that? Nope. Copy it down. The y, can I simplify too? Nope. The second x in the denominator. Can't do anything with it. What about negative 2/2? Do we see that? Yes or no? Okay, now how are those attached? That's not me. Somebody is vibrating hardcore. Like, I hear it on the. Oh, that's what it is. Now, what do I do? Is it you? What do I do? Shut up. What do I do? How are these attached? The x's are attached how? By division. So what do? Subtract them. So this is x to the negative 2/3 minus 4/3. Y to the 2 minus negative 1. Yes? We good? Negative 2 and negative 4 give you? Yep. Over 3. Minus a negative gives you a positive. So what's 2 plus 1? What is negative 6 divided by 3? Negative 2. Now what? Negative exponent. Do I like negative exponents? No. So play the game. Should I stay or should I go? So y cubed stays, x squared goes. Let's go ahead and do the last one here together since you guys know what you're doing. What do I do? Cancel 1 on the 9 and multiply those exponents together. So this is going to be 9 to the 1/2, x to the 4/2, y to the negative 2/2. What does 9 to the 1/2 mean? It's not half of it. Thank you. It's the square root. The base is 9. The power is 1. The root is 2. Yes? Do you understand that? Okay? 4 divided by 2 is going to be, this is an x. That's going to give you x squared. This is going to give you y to the negative 1. What is the square root of 9? So this is 3x squared y to the negative 1. Am I done? Play the game. Should I stay or should I go? What stays? 3x squared stays. What goes? Now I'm done. I have done over 13 homework problems with you. I have done a ton of them with you. You guys should know what you need to do for homework.